Okay, let's talk about how you deal with these sorts of problems. So this is the kind of question where you have to calculate how much will dissolve in a solution. So looking at this, we have to first understand what the graph is showing. And for those of you watching this, I'd suggest looking at the graph you have on your printed handout because it may be larger and easier to see this, I'm not sure. If we're asked how many grams of sodium nitrate are soluble in 100 grams of water at 30 degrees Celsius, first of all, in order to answer that, we have to look at this graph and see what we're dealing with. So first of all, looking at all these lines all over the place, what are they even showing? We need to begin with that question. So solubility curves tells us a bit, it has to do with stuff dissolving, but that's still kind of vague. So let's look at more specific, well, let's look at other parts of this graph. Now look at the x-axis, we see temperature, degrees Celsius, and then the y-axis, grams of solute per 100 grams of water. So what's that saying? Okay, so that's the temperature of the water, and this is how much stuff you can dissolve in the water per 100 grams of water. So it's saying how much will 100 grams of water hold? Now notice some of these lines curve upward, like this one for example. What it's saying is the higher the temperature, the higher the line. Do you see it? Look at that. Do you see that? The higher the temperature, the higher the line goes. What that's saying is as you increase temperature, this stuff is becoming more soluble. And maybe I'll bring it up on the previous slide here because I want to point out, and I'll re-highlight that line here. If we're looking at something that gets more soluble as the temperature rises, that means you're able to dissolve more and more per 100 grams of water. That's exactly what a solid does. Okay, so this is a solid, this KClO3, potassium chloride. On the other hand, if we compare that to, let's say, NH3, which is ammonia, you'll notice a line that's curving the opposite direction, rather downward. There you go, I'm not doing a very good job of tracing today. But regardless, you'll notice as temperature increases, solubility decreases. So the higher the temperature, the less NH3 or ammonia will dissolve in 100 grams of water. So if temperature rises and solubility decreases, that would be a gas, where the higher the temperature, the less can dissolve in water. So anyway, having looked at that, let's look at another way to use the graph, because again, we're being asked this question, how many grams of sodium nitrate will dissolve in 100 grams of water at 30 degrees Celsius? In order to answer that, we've got to say, first of all, look at this label. It says, this tells you how much will dissolve in every 100 grams of water. We're being asked how much will dissolve in 100 grams of water, so that means we can just read the raw number straight off the chart. So let's do that. Let's find sodium nitrate, that's this one here. 30 degrees Celsius, that's this number here. So I'm going to trace this number up here to the sodium nitrate, and then trace it from there over to the y-axis. That'll tell me how much will dissolve. So I trace it right there. I say it's about halfway between 90 and 100, maybe a little closer to the 100. So you can make an argument for 95, 96. I think I might have curved my line a little too far upward. So I'm going to say, it looks like it's about here, about 95 grams. So I'm going to say, okay, it looks like it's about 95 grams approximately. 96 grams is fine, 97 grams is okay, 94 grams is okay. What's not okay is to be like, oh, it's 100 grams. I mean, look, clearly it's not. Or, oh, it's 90 grams. No, clearly it's not. Okay, so within reason, variation is totally acceptable here. Now, this is how you read the number off the graph, but you do need to show your work on a test. And this is not sufficient for work. In fact, that's why one of the things on here was like, oh, it wasn't animated in the right order, but it says this is not how you show your work on a test. So the way you do show your work is this one. Now, what's going on here? Said, okay, if you're going to solve this question, the first thing you write is you're given. You're given 100 grams of water, so you write that here. The next thing you write, this came from the graph. You say, okay, potassium chlorate, right here, 15 degrees Celsius. That's right halfway between 10 and 20. So potassium chlorate is this line. And I trace it over, and I'm going to say that's about 8 grams of potassium chlorate. Oops. That will dissolve. That's my estimate is 8. So I'm saying 8 grams of potassium chlorate will dissolve in every 100 grams of water. This number comes from here, from this label. If this number was different, then this number would be different. But because it says 100 grams here, you put 100 grams here. So for every 100 grams of water, 8 grams of potassium chloride would dissolve. So think about that. If you had like 200 grams of water, this would be 16. 300 grams of water, this would be 24, like so on and so forth. Okay, this is just per 100 grams. Because of that, by the way, you'll notice 4 sig figs. This is 1 significant figure, and this is infinite significant figures. Yeah, that's the symbol that means infinity. So infinite significant figures. This number does not affect your rounding. Do not let it affect your rounding. 1 sig fig means a final answer with 1 significant figure, and so this is like what you would box right here. Okay, all from the chart. This is how I want you to show the work on the test, because this is your given, this is what you estimate off the chart, and there's your final boxed answer. This would need to be done for this one also, as in like 100.0 grams of water times 95 grams of sodium nitrate for every 100 grams of water gives an estimate of 95 grams of sodium nitrate. Okay, that's how you go about doing it on the test. So to you, the viewer of the video, I suggest doing the same thing, like, well, using the same thing for any kind of calculation of this sort. Now, this question right here, I would suggest practice it. Pause this video right now, practice it, and then I'll put the answer up. You're going to use the same sort of idea, though. Let's see if you notice that this is going to change your calculation, right? So take a moment, give it a thought, try it out. If you do, or if you did, you're going to hopefully wind up with a result that looks like this, where you took your given and put it right here. Because this graph says per 100 grams, it's still per 100 grams. And then you owe NH3 at 80 degrees Celsius. So you find 80, trace it up to the NH3 line, and then bring it over, calling it about 14. This looks like about 14 or so. 14 grams, so 200 times 14 divided by 100. That's why it winds up with that. Which, by the way, 4 sig figs, 2 sig figs, infinite sig figs, 2 sig figs. This is, once again, going to be a thing where there's variability. If you said 15, that's okay. If you said 13, that's also okay. Yes, I know that can make a big difference here, but it's all okay as long as you have a reasonable estimate here, and as long as this and this are correct, then you're fine. You're going to get credit on the test, even if you have a bit of a varying answer. So, having said that, I would say try this one out, and I'll put the solution up in just a second. There you go. Once again, potassium nitrate. You find that here, 20 degrees Celsius. So trace this up to the potassium nitrate line. Oops, I went too far. There you go. Potassium nitrate line is right here. So trace up the potassium nitrate line. I come over from the potassium nitrate line. We call it about 32 grams, 33 grams, 31 grams, 34 grams, 35 grams. These are all reasonable estimates. And so I'd say any reasonable estimate here, even though that will cause this number to change, is fine. Something to consider though. What if you had estimated 33 grams of potassium nitrate? Your calculator would spit out an answer of 165. And that would be wrong significant figures. 4 sig figs, 2 sig figs, infinite sig figs. If this is your answer, then you need to round to 2 significant figures, which means this would turn into this. Right? So make sure to pay attention to significant figures, because if you got 2 sig figs here, you got 2 sig figs there. You want to make sure you round correctly. All right, having said that, now for this last kind of question, what do you do if you're asked not how much will dissolve, but how much remains? Because here's a funny thing. You can dissolve, say, salt or potassium chloride or whatever in water, And you can keep adding more and more and more. Like some potassium chloride here, I could add water, I could add some of this to water, and I could add more and more and more and more, and at some point, the water's holding it can hold. It's like a person picking up a book. A person can pick up 1 book, 2 books, 3 books, 4 books, but at some point there's a limit and you can't pick up anymore. So what happens? If you put too much salt in or anything, the water will dissolve what it can, and the rest will just float to the bottom and just sit on the bottom undissolved. Even if it's an otherwise highly soluble compound like this, if you add too much, the rest will just sit undissolved on the bottom of the container. So here's what we're going to do. We're going to say, okay, you put in 150 grams. We're going to subtract out what dissolves, and that'll tell us what's left over undissolved on the bottom of the container. Here's what it looks like. You got to do the same setup, write what you're given. So 200 grams of water. At 70 degrees Celsius, we estimate that this chemical is going to be able to dissolve exactly 60 grams. That's what this decimal is here for, because we're going to round to the nearest whole number. So we want to make it 2 sig figs. So we're going to say exactly 60 grams will dissolve. And then when you do that calculation, that's going to give 120 grams are able to dissolve. But you added more than that. You added 150. So we're going to say, fine, 150 minus 120 leaves 30 grams left over. And as far as significant figures go, we're going to say, 150.0 minus 120 is 30. Keep in mind, you got to watch your sig figs. This is subtraction. You don't count sig figs, you count decimal places. So this is your last sig fig here, this is your last sig fig here, we round here, which means this should be the last sig fig. So this is a 1 significant figure answer, whereas this is 2 and this is 4, because we're not counting sig figs, we're counting decimal places, so you got to round correctly. All right, so that's the reason why this becomes your final answer, is because again, you take what you started with, subtract out what will dissolve to leave what's left over. So that should cover